Hey everyone, welcome again. So for the next session, we have Kennedy here with us. So I'm just going to give a brief introduction. Kennedy currently works as a cloud security engineer at Mattermost. He's dedicated to disrupting cloud security engineering practices with chaos engineering and also heralding the notion of continuous security verification. Also, just a couple of things. You can post your questions directly on the session chat, or you can add them to the Q&A session, and we'll take them after the session. Right? All right, Kennedy, over to you.
Hello, everyone. I want to start by thanking you for staying this late, or depends on where you are. Actually, here in Germany, it's about 30 minutes to midnight. So thank you so much for staying for attending my talk. And I want to talk about chaos engineering for cloud native security today. And basically, I want to start with some sort of introduction. So just to set things up a little bit, get my speaker notes out of the way. Right. So a little bit about me. My name is Kennedy Torkura, and I'm currently a PhD student at the Hasselplattner Institute. And my PhD has been about cloud security, cloud native security, and basically how to make cloud security to be more effective, to be more efficient, and to move at the same pace with the current trends that we are seeing these days. I'm also aside my PhD, I'm also working at Mattermost as a cloud security engineer. And so a lot of the things I'm going to be talking about this today is basically based on the research that I've done with my colleagues around the topic of cloud native security. So basically, let's start with some kind of definition. So what is cloud native security? Unfortunately, there is really no good definition that encapsulates, what cloud native security is all about. There is no agreed definition. So I will just try to give some kind of analogy or try to give you pointers to, some sort of architectures or that kind of try to define what cloud native security is. And to do this, I want to talk about the forces of cloud native security, which essentially is a model of security that has been proposed by the Kubernetes security team. And basically, what they have proposed is this diagram that we can see. On this diagram, we see a kind of architecture, which is a cloud native architecture, and the core of this diagram is about defense in depth. And what this diagram tries to let us to know, especially as security professionals, is that security is in the cloud native world is all about you ensuring that you have security at every abstraction layer. And that will begin from the outermost layer, which is the cloud layer. Mostly it's going to be the public cloud infrastructure. You're talking about Amazon Web Services, Google Cloud, Azure. And you're gonna have to make sure that you have security at this layer if you're into the cloud native world. This entails you understanding the kinds of security problems you will have, you understanding the shared security and shared responsibility model, and making sure that you really have that mindset that you're moving to the cloud, and security in the cloud is actually different from what you have on premises. The next layer is the cluster layer, and at this layer, you have, orchestrators. Majorly, we have Kubernetes nowadays. Mostly, people use Kubernetes, and the idea here is people want to be able to, outsource everything about deployment to this layer, Kubernetes. And there are also a lot of security problems that have come out from this layer, and a lot of products are beginning to tackle these problems. And these are really new problems that have not been known before now. And also, you have to have a very good understanding of the problems you face at this layer so that you can prepare yourself. The other layer, which is a bit inwards, the second before the last one, is the container layer, which majorly you're talking about Docker security. You're beginning to look at things like, are you sure that your container is deployed well? Are you sure that your like the container registry, you're taking care of the security problems that might come out from this layer? Are you sure that you're taking care of making sure that you're not importing already weaponized containers into your infrastructure? And the final layer, which is the innermost layer, is the code, which is actually the code that developers build. And this is much more closer to what we've been doing in the last decade. But now the major change is that now the codes are being pushed at a more rapid cadence to the production environments, and we also have to make sure that we are taking care of the vulnerabilities, whether you're using open source code, you're making sure that every time you make a change, you have some sort of security model or some kind of security checks that are kind of integrated into your continuous integration pipeline. So basically, all what this model talks about is making sure that you deploy a defense in-depth security model. And why is it important to even look at security in this way? Why do we not continue to use the same models that we have been using, in this for preventing cybersecurity, cyber attacks? So what we observe is that over the last years, we have seen quite a number of attacks that have targeted cloud infrastructure. And it dates back to when we saw things like attackers, compromising the infrastructure of Tesla, using that infrastructure just to mine Bitcoins. And later on, we started seeing things like exploitation of S3 buckets, where attackers went there to take over the data that was there. They were able to exfiltrate a lot of sensitive information. And of course, this still happens today, but actually we're even beginning to see much more advanced attacks. And what we see on the screen, this graph is a graph that was released by the Aqua Security team in the Cloud Native Threat Report for 2020. And you will see here that as at 2019, actually, when they started, when they deployed their honeypots, they started noticing just not so many attacks. And as at towards December of 2019, these attacks began to increase, and up to this first half of 2020, these attacks actually became very, very high, very, very much, and much complex. These attacks, according to them, were designed by organized criminals, and they were designed to actually evade many kinds of detection. And obviously, we see that from this research and many other ones we have seen, that the cyber criminals are beginning to understand the cloud native environments much better. They're getting better at constructing their attacks. They're getting better at getting all the kinds of targeting the cloud native infrastructure. And it is pretty important that everybody who is beginning to use cloud native infrastructure or even cloud infrastructure sort of tries to understand and puts in sufficient measures to contain these kinds of attacks. So let's look at some of the reasons why these attacks are actually improving, or are actually increasing, not improving, increasing. And the first thing we want to talk about is complexity. And complexity is actually not a new thing for cybersecurity. As a matter of fact, in 1999, Bruce Schneier wrote an article, A Plea for Simplicity, and the major topic, the major message was passing through this article was that complexity is the worst enemy for security. And as a matter of fact, we don't see things getting better. What we observe is actually our systems are actually getting more and more complex. Here we see some of the Death Star diagrams, some 5 or 6 years back from Netflix and from some other early adopters of the cloud infrastructure, of early adopters of distributed systems. And even as then, they already had complex systems. And the challenge with complex systems is that for security people to be able to defend, they have to understand what the systems are, and they have to understand it so that they can defend it. Either they're using already security tools, or they have to design their own tools. They can only design good tools based on the depth of understanding they have, about these kinds of infrastructure or these kinds of systems. Let's also talk about another thing, and that is about misconfiguration vulnerabilities. Again, this is something we have seen on the increase in recent years, and according to Gartner, 99% of the cloud incidents that are going to happen up till 2024 are going to be because of users' faults, and these faults are because of misconfigured resources. And the question is, why is this happening? And basically, I can summarize the reason for this these kinds of developments based on 2 points, actually. First is knowledge, and knowledge is that the cloud systems are still evolving. People are still trying to understand what they are, and there is a lot of misunderstanding about who takes care of what, especially when they move to the cloud. We have actually spoken with a couple of people, and they tell you they trust the cloud. They trust that whatever they move to the cloud is going to be secured by the cloud service providers. So there is that knowledge gap. When people move to the cloud, they're not very, very sure of their responsibilities. They're not very, they don't have a good understanding of how the cloud works, from a knowledge perspective. And aside that, we got the tooling support. So in traditional systems, when you adopted a certain technology, you needed to just understand it to some certain extent, and the balance understanding was what the tool was supposed to do for you. And that's why we use tools, to kind of augment where our knowledge ends. But today we have that even the cloud systems, they don't have very, very good they don't have very good support. And I just have a very simple example here to kind of explain further this what I'm trying to say. You see here we have a policy, which is an access control policy for Amazon Web Services. This is a small policy, so it's quite simple, but we have a more complex policy. And these policies are really important because they define to a very large extent who has access to what resources on the cloud, and what kind of access they have, more like authentication and authorization. And basically today, most companies, or human beings, are supposed to sort of maintain these policies, to write them, to edit them, to use these policies to keep the environment secure. If you compare these systems to things like Active Directory, underneath Active Directory, you also have these kinds of policies, actually in XML, some also in JSON, but people do not go in to edit or to maintain these kinds of these files. And so based on this, we clearly understand that we need better tools that are able to take off this burden for humans. And of course, this will probably help to take care of the misconfigurations problem. And now we come to another problem, which is about speed and security. And basically, most of us move to the cloud because it helps us to digitally transform our organizations. It helps us to adopt all of the cool technologies, all of the cool concepts that are, that are kind of invoke things like DevOps, CI/CD pipelines, helps us to shift left. Unfortunately, most of these transformations, most of these new cool ideas and concepts that we're adopting, they are not, they don't work well for security. They don't work well because, they make the whole environment to become really, really dynamic. And unfortunately for security, the traditional model, which we have been used to in the last decades, has been kind of very static environments where things do not really move, or things move really, really slow. And most of the security technologies or models that we have are designed for this kind of environments. and therefore they are really struggling these days, to catch up with the current trends. So eventually we have something like that. The modern security guy or the modern security, the tools are like that. They are really confused, struggling to catch up with the current technologies, trying to catch up, trying to understand, the ecosystems. And in the end, you find out that there are quite a number of security problems, data breaches also. So let's now cross over to security chaos engineering, and I would like to kind of try to explain how security chaos engineering helps, and probably how it can, how it could be deployed, how it could be used, how it could be used to compensate for the lapses in security. And by way of definition, security chaos engineering is the identification of security control failures through proactive experimentation to build confidence in the system's ability to defend against malicious conditions in production. Now, this is a definition that was put up by Aaron Reinhardt, which incidentally is one of the first people who started, applying, cybersecurity to chaos engineering. And the key point I want to point out here is about security failure, security control failures. And because it's always the question when I speak with a lot of people, they are trying to figure out what's the connection between chaos engineering and cybersecurity. And one easy way to look at it is that failures can have different kinds of impacts. And I will talk about it more in next slides, but you could have failures that impact on security. And this is where security chaos engineering comes in to begin to understand those sorts of failures and to try to, bring remediations to them. And to further differentiate these two concepts, chaos engineering, at least what we see in most tools, addresses availability problems. And it uses resiliency patterns to sort of address these problems, things like timeouts, bulkheads, circuit breaker, and all of these patterns are being built into different technologies, microservices, Kubernetes, and they try to detect this sort of availability problems early enough so that they don't become so bad that they actually begin to affect production systems, customers, and things like that. On the other hand, security chaos engineering also addresses availability, but this time around you're talking about things like availability problems that are caused by maybe denial of service attacks, such things, because this time around they begin to affect things like confidentiality, integrity. So security chaos engineering tries to focus on the faults that will impact on integrity. By integrity, you don't want you want to check whether your resources, your files, your systems have been modified. You want to be sure that only people who are supposed to have access to certain things, have access to those things. And how does security chaos engineering function? Basically, in security chaos engineering, you're trying to verify security patterns. You're trying to verify security controls. And this might fall under preventive controls, for example, firewalls. You want to verify whether they are working as they should. You don't want to assume that you have firewalls, that are supposed to protect your infrastructure and they are working well. Detective controls like intrusion detection systems, corrective controls like incident response systems. You want to make sure that these systems are positioned and they are functioning as they should. You don't want that verification to be done by attackers. You don't want an incident to occur before you begin to react. So at the end of the day, one of the core functionalities of security chaos engineering, is to help you to detect blind spots that are not easy to understand. In complex systems, you want to be able to detect where your security controls are failing or they are not even covering. You want to use this as a guide, to make decisions. Now, I want to briefly take us through sort of our journey into security chaos engineering to kind of give more context. And our journey started from we actually had we had a project with our academic partners. In this project, we were to come up with a way to, to help to defend against attacks for cloud infrastructure. And this was more like cloud identity and access management and cloud storage. And at that time, and even up till now, these kinds of cloud resources do not have firewalls. So you have S3 buckets, they do not have firewalls. IAM did not have firewalls. So what we did was to come up with a sort of way where we are getting the states, of these resources over a specific period of time and comparing them consistently. And by doing that, we were able to sort of come up with a way to detect when things went wrong, when there were, suspicious activities. So what you would call today as a cloud security posture management system. Now, at the end of the day, we were able to kind of protect this system, and it got to the time where we wanted to sort of verify and understand if at all what we have designed works as expected, because from a scientific background or from a scientific perspective, it becomes really important that whatever you propose, is verified, and you have to really think about it. You have to demonstrate while writing papers. Because of that, we started thinking about how to test our systems, to test how efficient they are. Now, we looked out at the what we have or what other researchers use, where they use things like, Metasploit and Kali Linux. These are offensive security tools that are commonly in use, for these kinds of experiments. Unfortunately for us, they weren't suitable enough, and therefore we had to look out for, for other alternatives. And so we kind of went out there. We did a threat model of our landscape, and then we started, attacking our systems, writing scripts to implement this kind of the attack surface that we saw, and writing scripts to exploit our own systems and to see whether we are able to detect these attacks. So this is an example of what we did. And here you see a simple attack path where we start and we create a user Bob. We get the buckets in the cloud. We select a random bucket. Then we create a malicious policy and assign that policy to Bob. And also Bob has access to that bucket. And essentially what we want to find out here, firstly, is if we were able to detect that a random user called Bob all of a sudden has access to a bucket. And also we could also check whether we were even able to detect that a new user, somehow appears in our environment, or if we were able to detect that a new policy, appeared. So this was kind of how to test, and it's also a nice way to sort of see or to test systems to see if they are responding as they should. So these are some of the, this is more like what we did. We had different modes of operation in terms of the intensity of the attacks, 30%, 60%, 90% levels of intensity, and we could chain different attacks, creation of things, modification of resources, deletion of some resources, and stuff like that. And in the end, we were able to come up with a few papers. Some of the papers were more like testing systems. Some of them were actually focused on security chaos engineering itself, where we tried to look at the term holistically. We tried to connect it with existing publications like dependability, and try to sort of do some research and to see how useful it is from an academic perspective. And eventually we had also the opportunity to contribute to the first security chaos engineering book, which was published last year in December, where we wrote together with Aaron Reinhardt and Kelly Shortridge, and that was actually a very good experience for us. So I will quickly rush through another thing we did, which is more like the security chaos engineering feedback loop. And the idea for us to come up with this loop was to kind of come up with, kind of construct a very nice way, a constructive way, actually, for doing security chaos engineering experiments in a way that users can have value, in a way that they can make the best use of these experiments. And the first is very simple: execute, meaning that you gotta have to clearly define why you're doing those experiments. What are the hypotheses that you want to test? Then you have to monitor the experiments, and basically you will see that some of these steps we're talking about are really aligned with with chaos engineering. Monitoring is really important. You have to have logs or a logging system. You're going to have observability. You want to be able to step in to stop, to stop your experiments if they begin to go by the wayside, of if things begin to get wrong. Actually, to analyze is really important, and especially for security, you want to understand the threat agent. So you've done your experiments, you've gotten the results, and you want to from the results, you want to understand the kinds of threat agents that can exploit, what you found out, the attack vectors they will use as vehicles to attack, the weaknesses that you found. You want to understand, because in the end, you want to be able to fix those problems, this kind of security controls that were breached, the technical impact as well as the business impacts. This is very important for analyzing your findings. You want to plan, because of course this is going to come in the end. You have a backlog of things to do. You want to be able to push that, to whoever is responsible to fix, and to plan the next iteration so that you can, continuously improve on your system. And of course, the last is sort of a knowledge base, and basically we have the idea here is we see security chaos engineering as a way where you can get knowledge, which will become like a knowledge base where you bring it together and put it together with your threat intelligence source, with all the information you're getting from different sources of information, and you're using it, to improve your system. You're using it to build, for example, rules for your firewalls, policies for other kinds of systems. So just a little bit, a little bit about the future. So we imagine that in the future, security chaos engineering is going to be somewhere in between the kinds of cloud native security tools that are coming out today. We have things like the cloud security posture management, cloud access security brokers, and then cloud workload protection platforms. Now, the thing is, most of these tooling are really, really limited to different abstraction layers. For example, the cloud security posture management is for the control plane of public cloud infrastructure. And the cloud workload protection are really looking at Kubernetes and maybe virtual machines. But the good thing about security chaos engineering is you can actually apply it to any abstraction layer, and you just have to be a little bit creative and to think about what you want to do, and to have the means to to implement it. So we see security chaos engineering being like somewhere in the center of this tooling, or this upcoming cloud native security systems, and just kind of being like in the center and putting them together, stitching them together, and testing them and making sure they're working very well. So thank you very much. That brings me to the end of my talk, and I will be willing and really, really happy to answer your questions.
Hey, Kennedy, thank you. That was pretty informational. So let's head over to the questions. The first question we have is, what are the security patterns that you are recommending for cloud resources?
Sorry, can you repeat again the question?
Sure. The question was, what are the security patterns that you're recommending for cloud resources?
Well, the security patterns. So basically, the security patterns they are not really changing from a cloud, from a security chaos engineering. So I talked about protective controls, defensive controls, recovery controls. So they are not really changing, but security chaos engineering can be used to improve on any existing pattern entirely.
All right. I hope that answers your question. Also, we have another question. What do you think about service mesh and security introduced with technologies such as ISTO?
Well, that's actually a very good question. So service mesh and Istio are really coming up with a lot of good security techniques that help to take care of security from the front, more like a gatekeeper. And the question is, if you deploy it, you want to understand if at all you deployed it correctly. And this is going to be something that is going to be dependent on your knowledge of that of Istio or service mesh. So if you didn't deploy it well, the question is, how do you know if it's well deployed? And there are just two options. Either you exploit it and you discover you are exploited, or you use a security chaos engineering to test and you probably detect and you kind of you fix it.
Cool. We have one more question from Abhishek. What have been the changes in security paradigm since the evolution of cloud native, and how is it different today?
Wow, that's I think a lot has changed. A lot has changed. The first is that now you have different models. You have containers, you have Kubernetes, and you have the CI/CD pipeline. And now developers are deploying, much faster than before, and they don't want security. The normal security checks are not being conducted. Because usually in the past, security checks take time and they're usually like a gatekeeper at the very far end of the continuous integration pipeline. But now security is beginning to move leftwards as other systems are moving leftwards, and these checks are also becoming more lightweight and more faster. But of course, this brings a problem because if you're running tests before for like 15 minutes and now you're told to run it for only 2 minutes, it means you have to compromise on the quality of checks you're going to do. And that means you have to think about how you're going to compensate for the remaining time or the remaining things you didn't check, which is really a headache. So that's just one example, and there are so many other things that are changing.
Got it. So we have another one from Abhishek. What are the observability elements in cloud native security?
Oh, that's a great question. So basically, there is no special observability for security. For security, you could basically use, even the best thing you want to do is to make sure that you choose just the best observability tool and see how you can push your logs or you can configure it to take in your security systems. And I think most of the tooling today, they're really doing a good job. They consider different kinds of systems, and it might also be that you have to do a little bit of work. So a little bit of work means you want to be sure that, for example, your logs are configured in a way that can be ingested by the observability tools. So they're not, in a nutshell, there is no special one. You just have to pick anyone you're used to and then think about how to make it to conform to your own security tool.
All right. This is from Prithvi. How do you evaluate the role of an SRE or a DevOps engineer in carrying forward the developments of a cloud native chaos engineering project?
Yeah. So SREs, DevOps, basically they are, the definition is really I would say, conflicting. So some people actually define it, or some people, SRE and DevOps actually mean the same thing, to some people. And evaluating them also is a function of your unique environment and what the job is supposed to be like. In some companies, they want to make sure that every single thing is automated. In some companies, it is semi-automated. So it's really a contextual question, and you have to it's case by case.
Great. Thanks, Kennedy. Those are all the questions that we have for now. Guys, if you want to continue the conversation or if you have any more questions, we'd be happy to answer them. Just hop onto our Slack channel. So we bring this session to an end here. Thanks, everyone. Thanks, Kennedy.
Thank you very much.